it's impending motion, if it's about to move. So let's take a look at this. We have a 500 Newton force being pulled to the left, and we have a P on B going to the right. Right, so there's two possible surfaces where there's movement, right? There could be movement between A and B, and there could be movement between B and the ground. But we really don't know where the motion is yet. The fact that they're asking us, though, for the maximum, see B, it says maximum force P. If they're asking you for a minimum or a maximum force P, where are they implying the motion's going to be? B to the right, which means between B and the ground. Is everybody comfortable with that? Because they're asking us what the maximum force P is, you now know that P is going to cause impending motion. And if P is going to cause motion, it's definitely going to cause motion down here. What just happened? Oh. It's definitely going to happen here, right? Because if P is moving this, it's definitely going to happen here. But here we're not so sure whether there's impending motion or not. It might be that A is going to stay with B. Santiago.
If you're sliding both boxes in opposite direction, does the coefficient of friction change?
No, because the coefficient of friction has to do with what type of material it is. So if you have two rubbers, or a rubber and wood, or a rubber and metal, that's what determines the coefficient of friction. And we can look them up. Okay? So it has nothing to do with which way, because if B is going this way and A is staying still, that's the same thing as B going this way and A going that way. Okay, so it's the material that determines the coefficient of friction. So if we know that it's 0.3 between here and it's 0.2 here, what would you say about the material? Whereas it's rougher between the two. These might be the same material, and maybe this is linoleum or something smoother. That's all the frictional force, the coefficient is telling you. So does everybody understand now, looking at this, if they're talking about a maximum force P, then there is going to be some motion between the ground and B. But there may not be motion between A and B. And does it make sense? Oh, I was thinking that maybe this one was okay. Does it make sense that if the coefficient of friction between here is larger than here, there's more potential for it to slide here and stay here? I think these are the hardest parts about the friction equation. About friction problems. You know that's all it's doing is adding another equation. So it's the same kind of problems. You have to figure out which way it's going. That's not a problem either. But the idea is it actually moving? Can we apply the friction equation or not? Now luckily, Brandon told us that we only need 5 equations. So we need two force X on one body, two force X and Y on one body, X and Y another body, and we only need a 5th equation. So that would be the friction equation where? Between B and the ground. So we don't need the friction equation in between those two. Okay. Mark, you had a question?
I was thinking that the potential for motion along the floor would be, the friction would be greater because there's greater normal force there. Even though the coefficient friction is smaller.
Good point. Good point. So what I was saying about the coefficient of friction, the coefficient of friction has to do with the surface. So the surface between A and B is rougher than the surface between B and the ground. That's what this tells you.
Yeah.
But what he's saying is the normal here would be greater, so the frictional force it needs to overcome might be greater here. And let's see when we do the numbers. Good point.
So we just pick a scenario and run with it, or
Scenario, what do you mean?
assume that top block's not moving.
Yeah, but let's wait, we're not there yet, we're just kind of talking. So here, looking at all the forces present in the problem, we need 5 equations. But looking at only what they want us to find, how many equations do we need here? If they only want us to find P, how many equations do we need? 1. We need 1 equation because we have 1 unknown. And how many bodies do we need to analyze? 1 body. But this is similar to the frame problems, where they may only be asking you for 1 unknown, but because there are so many unknowns in the problem, you might need more than 1 equation. Does everybody get that? Okay, so we only need to find 1 unknown, so we really only need 1 body. But when we introduce all these other unknowns, we need 2 bodies, so we have to figure out, we're going to need 1 or 2 bodies to solve this problem. Okay, so now I want you to start and do the free body diagrams. Draw a free body diagram of A, draw a free body diagram of B, draw a free body diagram of A and B together.